All right, in this video, we're going to look at matrices, an introduction to them, and their formats. So a matrix is a rectangular array of elements. So you're thinking about something that might look like this. This might be an example of a matrix you might see in this course. And one of the first things we're going to look at here is determining the order of a matrix. Now, when we use the term order here, we kind of mean the organization it belongs to. And the way we classify that is we look at its dimensions. So you describe it by its number of rows by its number of columns. So in this first example, if I said, what's the order of this matrix, you would say it's a 2 by 3 matrix. It belongs to the order of 2 by 3. So it's like its classification. Then we're going to look at whether our matrix is in a specific format, what we call row-echelon form. And there are 3 conditions that have to be true in order for a matrix to be considered in row-echelon form. The first thing is the first non-zero element in each row must be a 1. So you can skip over zeros, but the first thing you run into that's not a 0, as you read left to right, must be a 1. We call these leading ones. Okay? The second thing that needs to be true, as you move down the matrix, these leading ones have to get farther to the right. Right? And then the last thing that has to be true, and this may not always apply, but when it does, it has to be true, and that is if you have a row of all zeros. So any row of all zeros comes last. So if you don't have a row of all zeros, obviously that doesn't apply, but if you do, it has to be at the bottom. So a nice kind of ideal situation might be something along the lines of, something like that. So the first thing I run into in each thing that's not a 0 is a 1. And as I move down, my 1s get farther to the right. Now, in this example, they made this nice little perfect diagonal of 1s, but that's not necessary. It doesn't have to work out that way. You could have something like that. That would also work. 1, skip over the zeros, 1, or you might have something along the lines of all zeros on the bottom, and that's okay too. 1, and then any row of all zeros comes last, it's on the bottom. All of those are in row-echelon form. A second format that we're going to be concerned about is reduced row-echelon form. And for reduced row-echelon form, the first thing that has to be true is the matrix has to be in row-echelon form. Let's be in row-echelon form. If that's not true, it can't be in reduced row-echelon form. So it already has to satisfy those 3 conditions we just mentioned. So the reduced part comes in by the fact that all elements in a column, remember columns go up and down, with a leading 1 must be 0. So, and let me look over here and pull out one of these examples. So let's say I pull out one of the problems we just looked at, and I look at this problem. I said, that was in row echelon form, but it's not in reduced. When I look at this leading 1, sure, that's a 0. But when I look at this leading 1, this 2 would have to be a 0. It's not, so this is not in reduced row echelon form. It's still in row echelon form, it's just not reduced row. Now, notice this -3, there's nothing wrong with this being a -3 because there is no leading 1 in that column. That does not affect, if there's no leading 1, that does not affect whether it's in reduced row echelon form or not. Or sometimes people, they get confused. They'll have something like this, and they'll say, okay, this one, yeah, 0. This one, yeah, 0. And then they look at this one. Now, this one is not a leading 1. It's a following 1. This is the leading 1 for that row, right? You read it left to right. That's the first one you run into. So it doesn't matter that there's a -7 underneath this 1 here, because that's not a leading 1. It only matters about whether this is a leading 1, and then you look in its column to see. Okay, so that is in reduced row. All right. Now the fun part, and I use that term lightly, is how do you turn something that is not, something like this original matrix I wrote down, into one of these formats? And the way we're going to do it is we're going to use what we call elementary row operations. And we're going to use 3 of those. And as the name suggests, these are working with rows of a matrix. Right, so the first thing you are allowed to do is you can switch any 2 rows, which ultimately means you can switch all the rows around. If you do enough switching and swapping, you can switch them all. But the rule is you can swap any 2 rows. The second thing you're allowed to do is you can multiply, or if you prefer, you can also say divide. But just realize when we say I'm going to divide by 2, what I really mean is I'm multiplying by 1/2. So that's why the rule is written this way. You can multiply a row by a non-zero number. And we're going to usually use that to make 1s. That's going to be the typical purpose of using this second operation. You'll have like this 3 here, and you'll multiply a top row by 1/3, and that'll make it a 1. That's usually the go-to for that, and what the point of using that property is. And then the third one, and it's going to be a little tricky at first, and I'm going to kind of break it down here. What we're going to do is we're going to take a copy of a row. So we're not actually going to change the row we're working with. We're going to multiply the copy by a number. And then add this to another row and replace that other row. Place that other row. So let's see these, and I'm going to use that first example I wrote down. 3, -4, what was it? 3, -4, 8, 2, 11, 13. And I'm doing this one because I made no effort to make these numbers work out nice. This is going to be nasty, and that's okay. That's we can handle it. So my goal here, with this kind of off to the side here, let me kind of indicate the steps I'm going to do. My goal here for row echelon form is I want to make this a 1, this a 0, this a 1, and then these other 3 spots are going to come out to be whatever they come out to be. I mean, I'm going to work with them. I'm not shooting for anything. And I'm going to do it in that order. Make that 1, make the 0, and then make the second one. Now, for reduced row echelon form, it's going to be similar, except I'm going to make my 1, I'm going to make my 0, I'm going to make my next one, but then I'm going to make this spot a 0, and that's going to be my 4th step. So this is for a 2x3 matrix like this, it's going to require at least one more step to do that, usually. We'll see how things play out. Now, first thing I want to do is get my first 1, and I have a couple options. First option is I could multiply the entire top row by 1/3 and make that a 1, but then I have to work in thirds. Alternatively, I could multiply the entire second row by a half, making those halves, and then switch the rows around. And I think that's what I'm going to do. But you don't have to do it that way. You could just multiply top row by a third. I think I just like halves better. So I'm going to do a half row 2. And now this is going to look like 3, -4, 8, 1, 11 halves, 13 halves. Okay. And then I'm going to swap row 1 with row 2. Remember, that's something we're allowed to do. We could swap rows. So now I have 1, 11 halves, 13 halves on the top row, and on the second row, 3, -4, 8. So got that done. I got my first 1. Great. My next goal is to make where the 3 is a 0. And the way I'm going to do that is I'm going to add a copy of the top row to get 0. So because I'm adding, I need to ask myself, what do I add to -3? Or what do I add to 3 to get 0? And that'd be -3. I just said it. All right, so -3, a copy of row 1, and add that to row 2. So let's think about what that copy would look like. That copy times -3 would be -3. And this is -3 over 1, right? So when you multiply a fraction, top times top, so -33 halves, -39 halves. And I'm going to add that copy, that red set of numbers, to the bottom row. Well, since I have some fractions here, maybe I might want to change this bottom row into fractions as well. Well, I'm going to leave 3 as 3, but -4, I'm going to change to -8 over 2, right? Common denominator of 2. And 16 over 2 will be the same as 8. And then I'll add the reds and the blues. And that'll be my new second line. So my first line, remember, we're actually just taking a copy of that first line. We're not actually changing it. So it's going to stay the way it was. But now I'm going to add the red numbers to the blue numbers. -3, +3, that's 0. -33 and -8 is -41 halves. Ooh, this is going to come out ugly. All right. -39 and +16, -23 halves. And like I said, I made no effort to make this look pretty. This is not surprising. It's coming out quite ugly, but that's all right. So now I have my second goal done. My third goal is to get this -41 over 2 to be a 1. And the way you make something a 1 is you multiply it by its reciprocal. So I'm going to do the reciprocal, -2 over 41 times the second row. So that top row is going to stay the same. And this bottom row, well, 0 times anything is still 0. -2 over 41 times -41 over 2. The negative times a negative is a positive. The 41s cross off, the 2's cross off, and you get 1. -2 over 41 times -23 over 2. Again, the negative times a negative is a positive. The 2's cross off, and we're left with 23 over 41. And now this is in row echelon form. And I want to put it in reduced row echelon form. So I'm going to go another step. And the other step I'm going to do is I'm going to try to make this 11 halves 0. And to make a 0, you always do it by adding. You add a copy of the other row, and specifically the row that has that leading 1 for that column. So I'm going to use this one to do it. So I'm going to take negative 11 halves times a copy of row 2 and add that to row 1. So that's not actually going to change row 2. So I'm going to go ahead and write that as 23 over 41. Leave it there because I have a feeling we're going to have some fraction work to play with here. So negative 11 halves times 0. That's, let me make that red again. So that's 0, or I'll make it blue. I'll make it blue because I don't want to run into that other blue. All right, so 0, negative 11 halves, negative 23 times 11, negative 253 over 82, right? 41 times 2. So now I want to add that to the top row. And this time the top row, I'm going to leave this as a 1. I'm going to leave this as 11 halves. But now I need to have a common denominator, 82. So I need to multiply 13 times 41. Figure out what that is. So 13 times 41. And there are calculators that you can just do this, add the fractions. 533. 533 over 82. Okay. I'm going to add those together, and that's going to give me 1 plus 0 is 1. Great. 11 halves minus 11 halves is 0. 533 minus 253, well, let's see, that's going to be a 0. 380 over 82. That looks like it reduces. So let's go ahead and do that. 23 over 41 and 190 over 41. And there you go. And now it's in reduced row echelon form. So we could have stopped at this step if we wanted to put it in row echelon form. But we go one more step to put it in reduced. Now, they're not always going to be this nasty. This one, again, I made no effort to make it not come out nasty. But, let's look at one that maybe is a little nicer and do that and maybe go a little faster. So let's say I had 2, negative 3, 1, 6, and I'm trying to make this look nice. So 1 and 8. There we go. All right. So first thing I want to do is make that first spot a 1. And I notice, hey, there's a 1 in that second row. So I'm just going to switch those rows around. Row 1 switches with row 2. All right. 1, 6, 8, 2, negative 3, 1. Then I want to make this 2 a 0. And I know to make zeros, I have to do it by adding. So I'm going to add negative 2 times a copy of row 1 and add that row to row 2. So negative 2 times row 1 is going to be negative 2, negative 12, negative 16. Add those 3 red numbers to the second line. So the top line is still going to stay 168. This is become 0, negative 15, negative 15. Now I want to make this first negative 15 a 1. And so we do that by multiplying by the reciprocal. So 1 over 15, second row. 1, 6, 8. 0 times anything is 0. Negative 15 times negative 1 over 15 is 1. Negative 15 times negative 1 over 15 is also 1. All right, now it's in row echelon form. So to put in a reduced row echelon form, I need to make this 6 a 0. And again, you make zeros by adding. So I'm going to do negative 6 row 2, a copy of row 2, and add that to row 1. And that's going to become, so if I multiply the bottom row by negative 6, it's going to be 0, negative 6, add those 3 to the top 3, 1, 0, 2, 0, 1, 1. So a lot of times that's about all you got to do. If it comes out nice, occasionally you can run in those nasty fractions, but don't let the fractions distract you. You can use a scientific calculator. Most can handle fractions for you to do that. And you could do this for even larger problems. If you had a 3 by 4 matrix, let's say, you would want to make this spot a 0, make a 0, make a 0. So first step, second step, third step. So the idea there is to make sure there aren't any other leading ones directly below your first leading one. Then you make your second leading one, make a 0 below it, then make your third leading one, and then start working your way back up. So make a 0 there, make a 0 here, and then make a 0 there. And meanwhile, there's, other numbers over here that you're working with at the same time, but that's not your goal. Your goal is to get these to look like that 1, 0, 0, 0, 1, 0, 0, 0, 1 pattern there. Okay, so that is an introduction to matrices and their formats.